All right, welcome back, everyone. Today we're looking at day 13. We're looking at some questions. We're getting ready for our test on Wednesday, and I asked for some questions from people during the periods today. I only got one that I want to look at, and then I want to just solve a couple of the more difficult problems from the review sheet in a way that I can walk you through. So if you can't just figure it out from looking at the key, hopefully this video will help you for those. The question today was over what happens when the limit as x goes to infinity of some function divided by another function, right? If we have this setup, limit x goes to infinity of f of x over g of x. Let's think about power, like what's more powerful, what's less powerful, right? So what if g of x was more powerful than f of x? If our more powerful function is on the bottom here, what would our limit as x goes to infinity be? Well, again, it might help to think for a second about what does powerful mean, right? Our most powerful functions that we've been looking at have x as an exponent, right? And as long as the base is a number bigger than 1. So like 3 to the x is very powerful. E to the x is very powerful. 10 to the x, those are very powerful functions. Kind of in the middle are polynomials like x to the 5th, x squared, things like that. Our least powerful functions are like our logs and natural logs. So what happens then if g of x is a more powerful function? For example, this. So think about this. When we look, x to the 6th is a more powerful function than x to the 5th is. When our more powerful function is on the denominator, we know that the limit is always going to be 0, as x goes to infinity. We also kind of know what to do when g of x and f of x are the same power. For example, this. So take a look at this setup. We have the limit as x goes to infinity of 15x cubed plus 2x squared over 3x cubed minus 5. We see that our most powerful in each one is x cubed. Right? So here we see, we want to ask ourselves, what's happening as x gets really big? Well, they're equally powerful. Right? When we have this, we look at the ratio of the coefficients on our more powerful terms. So our answer would be 15 over 3 or 5. So this one would be an example of g of x and f of x having the same power. What happens when the top is more powerful? For example, so if we see this, the limit as x goes to infinity of 3 to the x over x to the 6th. When we look at this, we have to be careful. Don't just look at the 3 and the 6's. Look at the fact that the top function here is 3 to the x. That is much, much more powerful than x to the 6th, as x gets really, really big. So we know that the rule is if the top is more powerful, our answer is either going to be plus or minus infinity. But how do we know if it's plus infinity or minus infinity? Well, we need to consider the signs that are going to be occurring here. So let's think about this real quickly. As x gets really, really big, and we need to know our answer is either going to be plus or minus infinity. But we can't leave the answer as plus or minus infinity. It's got to be one of the two. So we're going to determine, is this a positive infinite? Is this thing getting infinitely positive or infinitely negative? Well, let's think about plugging in a big number into the top of the function. 3 to a really big number, that's positive, right? 3 to a positive number is always going to be positive. Our sign on top is going to be plus. Also, a really big positive number to the 6th power is also going to be plus. When we have a positive divided by a positive, we get a positive. So our answer is positive infinity. Okay? But we kind of need to be careful because there are some tricky things, especially if we throw in negative infinity here. So let's take a look. So take a look at this setup here. Now we have the limit as x is going to negative infinity. All that means is we're plugging in an infinitely negative number in. Okay? And again, we consider what's more powerful, the top or the bottom. Well, once again, the top is more powerful here. So my answer is either going to be plus infinity or minus infinity. But I have to do a little bit of work to figure this out. So I know we're going to have infinity, but I need to determine the sign here. Well, let's think about what happens when we plug in a really negative number on top. We'll focus on the most powerful thing here, x to the 5th. If we take a negative number and raise it to the 5th power, what sign does it come out? Plus or minus? Think about that for a second. Well, a negative number raised to an odd power is going to stay negative. So that x to the 5th term is going to be negative. When I multiply that by 4, it still stays negative. So the overall sign of the top is minus. Now let's think about the bottom. On the bottom here, I have a negative number that I'm raising to the 4th power. Is that going to be a positive number or a negative number? Well, when I take a negative number and raise to an even exponent, it's going to become positive. But that positive number is being multiplied by -2. A positive times a negative is a negative, and the overall sign of the bottom is also negative. What happens when I divide a negative by a negative? Well, you get a positive. So I get an answer of positive infinity. The test doesn't seem to really hammer these types of problems very often, but occasionally they can, so we just want to be ready for it in case. The next thing that I want to go over is limit definition of a derivative. So I'm going to work on problem 4. I'm going to do both when f of x is 6 root x and the quadratic. So let's look at limit definitions of a derivative. So the limit definition of a derivative says that f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. And remember, we got that by looking at a secant line that connects 2 points on a curve, and we're just shrinking the distance between those points to 0, so we can get the tangent line equation. So I asked you to find f prime of x, and then I also asked you to write equation of a tangent line. at x equals 4. Okay, our first function was f of x equals 6 root x. Okay, so here's what I want to do. I want to find f prime of x using the limit definition. Okay, the problem explicitly says that. If you, on the test, if you go through and use the power rule, you will not get credit for the work here. The credit will be given for using the limit definition. So even if you know what the answer is going to be, it's important to do it, prove it using the limits. Okay? I suggest, at the end we'll do this, I suggest you also use the power rule to confirm that your limit definition of a derivative equals the power rule that you know works. So let's take a look here. The first thing I want to do is make sure my notation is good. Okay, so the first thing I want to do here is write this. Okay, so I'm using this equation. Right, I've seen a lot of kind of funky notation here, or just a complete lack of notation. We want to say f prime of x equals the limit as h goes to 0. Okay, now we want to do f of x plus h minus f of x in the context of what f of x is in this problem. F of x is 6 root x. During these two problems, I'm going to write f of x plus h in black, and I'm going to write f of x in red, just so we can see the difference here. So let's think of f of x plus h. Everywhere I see an x, I'm just replacing it with an x plus h. X is under the square root, therefore x plus h needs to be under the square root too. So there is my f of x plus h. Now I need to subtract f of x. I told you I'd be doing this in a different color. I think it's red. I don't know. I'm colorblind. So here we have our setup. Again, we need to have our f of x plus h, and we need to subtract our f of x. Notice that f of x here is a monomial, so there's only one term, so I don't need to put parentheses around that 6 root x. You're welcome to use them if you want, but you don't have to. In the second example, you are going to have to put that f of x in parentheses, because it's going to be a trinomial. Okay, so when we get to this point, we want to think about what's happening. Our first step with limits is plug in 0, or plug in the number in the limit to determine what we get. What's going to happen when we plug in 0 here? Well, this h right here is going to become 0, and so is this h right here. So I end up with 6 root x minus 6 root x, which is 0, over h, which is 0. So I end up with 0 over 0, which is a problem in functions, but not a problem with limits. We know how to fix this using limits. Okay? Well, if we think back to our strategies on limits that we looked at in the day, I think, 11 video, we'll say the first thing we do is factor, if we can factor. Well, we could factor out a 6 here, but that doesn't really help us on top. Right? We could expand, or we can't even expand in this problem. But whenever we see square roots, one of our best options is to use the conjugate. So that's 6 root x plus h minus 6 root x. The conjugate of that would be 6 root x plus h plus 6 root x. And oftentimes, when we multiply by the conjugate, we can get some things to drop out, and eventually what happens is we want to try and cancel out the h on the bottom. We can't cancel out that h on the bottom now legally, so we're going to try a method of using the conjugate to see if we can get it to drop. So I'm going to go ahead and solve this thing through, and I'll come back and kind of talk about what's going on. Okay, as you can see here, I multiplied by the conjugate on top. To keep the value of this fraction the same, I need to multiply the bottom by the same thing that I multiplied the top by. Now, I did go ahead and put our original expression in parentheses, because when we're multiplying two binomials now, we need to FOIL this thing out. We need to do so carefully. There's a couple of tricky spots here. Also, I'm not going to distribute that h into the bottom, into the denominator there, because that's the h I'm trying to cancel. So I want it to be in factored form on the bottom, so when I get an h alone on top, I can cancel it out. Okay, so now I need to go through and FOIL this thing. This is where we need to be very careful with our principles of math type stuff. So we have 6 root x plus h times 6 root x plus h. So on top here, I'm going to multiply the two 6's together to get 36. And when I multiply root x plus h times root x plus h, I get the quantity x plus h. It is very important that when you do this, that x plus h stays in parentheses like this. Okay? Now the reason I use the conjugate is because the o and the I in FOIL cancel each other out. This term and this term are the same but opposite signs, therefore they drop out. So now I need to just look at the last two terms. Negative 6 root x times positive 6 root x, that would be a negative 36 for the number, for the coefficient there. Root x times root x is simply x. Once again, I don't need parentheses around the x. I could put them there. I don't need them because x is a monomial. And on the bottom, I just want to keep that h factor. Okay. So now I'm going to go ahead and distribute that 36 into the x plus h and see what I can get to cancel out. Again, I want to get everything that doesn't have an h out of the top. That's my goal, so I can cancel it with the h that's on the bottom. When I distribute that 36, it's pretty clear to see here that the 36x and the minus 36x are going to drop. That's important because this leaves me with 36h on top, a monomial, and it leaves me with h times a binomial on the bottom. Because we're now multiplying on the bottom, we now can cancel out these two h's. This h and this h cancel each other out. So we're left with f prime of x equals limit h goes to 0 of 36 over 6 root x plus h plus 6 root x. So this is big because I was able to get the h's canceled that were causing a 0 on the top and a 0 on the bottom. Now, a lot of people get here and then they get stuck. What do I do with the bottom? How can I add those two? They're not like terms. Well, again, after we canceled our h's, we want to try replugging in 0 for h. And when we do that, we see we get x plus 0 right here. Well, we know that x plus 0 is simply x, so I get 36 over 6 root x plus 6 root x Now they are like terms. 6 root x plus 6 root x is 12 root x. And that can simplify to 3 over root x. So I end up with f prime of x equaling 3 over root x. Just to confirm, when you get your final answer, you can catch your mistakes by going back and doing the power rule, right? So I'm going to scroll back up and look at the power rule of this function. For this function here, 6 root x is the same as 6x to the half. Therefore, use a different color. Therefore, f prime of x, we'd have to use the power rule. We take this half and multiply by the 6, and we get 3x. And we have to reduce this power by 1. Half minus 1 is negative half. We could rewrite that as 3 over x to the positive half, which we could rewrite as 3 over root x. So the work that we did for the power rule matches the answer that we got using the limit definition, which is a good thing. Okay, if they don't match, you're doing one of the two wrong, or you need to simplify it more. Okay, so now we got f prime of x. Now we want the equation of a tangent line at x equals 4. So anytime we're looking for an equation of a tangent line, anytime we want an equation of a line, we want point and we want slope. Well, we already know the x part of the point is 4. How do we find the y part of the point? Well, y is just f of x. We just plug in 4 into our f of x equation. So we do f of 4. Which would be 6 times root 4, which equals 12. Now to find the slope of our tangent line, we want at x equals 4, we want to find out what is f prime of 4. Because we know that the slope of the tangent line is always related to the derivative. So we want to plug it into f prime. So we can see right up here, we have a nice simplified version of f prime of x. We have 3 over root x. Okay, so we want to plug in 4 for x. So I know my slope is 3 halves. And I can quickly write my equation as y minus 12 equals 3 halves x minus 4. And we're done. Okay, I want to do the second part of this limit definition of a derivative here. So let's take a look at that one. So now I'm asking the same question. I want to find f prime of x here using the limit definition, and then I want to write the equation of the tangent line at x equals 4. Okay? So once again, we go back to our limit definition, which says f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. That is our limit definition. Now, we have a new f, right? So we're going to have a new f of x and a new f of x plus h. So let's think about f of x plus h. Just replace all the x's with x plus h's. Put them in parentheses since they're binomials. And we get this. There's my f of x plus h, but now I need to subtract f of x. I'm going to do that in a different color. Notice here the importance of parentheses around our f of x function. Anytime f of x is a bi or trinomial, we're going to have to make sure we put parentheses around that thing. Okay, and we're going to divide the whole thing by h. The math is the algebra is a little bit simpler here, but there is just a lot more of it. So it's going to get a little bit messy, but it should be fine. The thing we need to remember about is x plus h squared is not x squared plus h squared. We have to FOIL that. X plus h squared is always x squared plus 2xh plus h squared. Very important. Okay. So I'm going to go ahead and expand this thing and start to solve it. This 6x squared plus 12xh plus 6h squared, I did two things. I expanded x plus h squared to x squared plus 2xh plus h squared. Then I distributed the 6 in. Okay, now I need to distribute that negative 7 up here as well. Notice how both the 7x and the 7h are both negative. Very, very important. Okay, plus 4. Now I need to distribute this negative sign. So now we have it fully expanded here, ready to cancel some things out. If you notice, the ones I write in red are always going to end up canceling out. So that minus 4 and that plus 4 cancel. The plus 7x and the minus 7x cancel. The minus 6x squared and the positive 6x squared cancel out. So let's kind of group together what we have left. I'm left with a 12xh plus a 6h squared minus a 7h. That's all on top. And on bottom, I have h. If you notice, every term that's left on top has an h in it. That's important because now I will be able to actually cancel that h out. Right? Factoring an h out of the top, here's what I get. Oops. Once I factor that h out, I can cancel it. Some students just cancel one of each of the h's without rewriting it in factored form. That's fine. Just know that plus 6h squared, you're only canceling one of the two h's out there. Okay? That's important because that 6 term needs to go away to get us our answer of 12x minus 7. After we cancel out our h's, we can plug in 0 for the h here, and we get 12x minus 7. And again, I already have this hooked up in an equal sign to f prime of x, but sometimes it's nice when you get your answer, rewrite it in one nice, easy to reference spot. Once again, we should go look at the original function and make sure using the power rule we get the same answer. We can catch a lot of our mistakes this way. Going back and looking at our original f of x here, this is already ready to go in ax to the n form, and we do see that f prime of x would be 12x minus 7. Remember, the derivative of a constant is 0. So we know that we did it right, and our algebra using the limit definition matches our power rule definition. Okay. Now lastly, I need an equation of a tangent line at x equals 4. So I need a point and I need a slope. I know the x part of the point is 4. So I need to figure out what is f of 4. Well, go back to your f of x, 6x squared minus 7x plus 4. So that will be 6 times 4 squared minus 7 times 4 plus 4. 4 squared here is 16. 16 times 6 is 96. Minus 28 plus 4. 96 minus 26 is what? 68. Plus 4 equals 72. So I know the y part of my point is 72. To find the slope of the tangent line, remember that's a buzzword in calculus, slope of the tangent line, we need to consider the derivative at 4. So I need to find f prime of 4. Well, this is why notation is important. We have all this work back here, but I have a nice circled f prime of x here, so I'm making sure that I'm plugging into the correct place. F prime of 4 will be 12 times 4 minus 7. 48 minus 7 is 41. So I know my slope is 41. Now I can write the equation of my line. I can say y minus 72 equals 41, x minus 4. So hopefully that answers your guys' questions. Please ask if there's a certain problem from the review sheet you want to see. Please post that in the comments below. And as always, make sure you like and subscribe. But any particular problem on the entire review sheet you want to go over, please comment with that, with the number, and we'll go through it. If I don't get any comments on that, I'll do a couple more in tomorrow's video. Thanks. Study hard. You guys are awesome. Peace.